Welcome! In this video, we'll analyze how the hanging mass P affects the block M through the tension in the rope. Let's begin by drawing the system. Now, let's identify the forces. On block M, the only horizontal force is the rope tension, which we'll call T. On mass P, the forces are its weight, 3 times 9.8 newtons downward, and the tension upward. Let's write Newton's second law for each mass. For block M along the horizontal direction, T equals M sub M times A. For mass P along vertical, 3 times 9.8 minus T equals 3 times A. Now we solve these equations simultaneously. Substitute M sub M equals 2 and M sub P equals 3, G equals 9.8. Adding the equations eliminates T, giving 3G equals 2 plus 3, A. Thus, A equals 3G divided by 5. Finally, we find the tension, which is the force transmitted to block M. From T equals 2A, substitute A equals 3G over 5 to get T equals 2 times 3G over 5, which simplifies to 6G over 5. Numerically, that's 6 times 9.8 divided by 5, which is 11.76 newtons. In conclusion, the hanging mass P generates a tension of approximately 11.76 newtons in the rope, which is the force exerted on block M. This tension produces the block's acceleration of 3g over 5 meters per second squared.